Today we are going to solve a simple question. This is the problem statement. Now I'll link this question in the description and you can read the problem statement yourself. But I will give it to you in a faster way. So what the question demands is basically you are given a list of words. Let's suppose the list is this: apple, banana, apple, orange, banana, banana, and apple. And what we have to return is a sorted vector from this original vector. Now, how this sort is going to occur is this. So basically, we have to sort it according to the number of times a word is occurring in this original vector, which is given over here. So the vector, string, and word. So basically, it's a list of strings. N is the size of the string. So here we can see apple occurs thrice, banana occurs thrice, and orange occurs once. But here's the catch: apple occurs thrice and banana also occurs thrice. So what? How we are going to distinguish between these? Who is going to come first and who is going to come second? We can do. We are going to do that alphabetically. So because apple is comes first alphabetically, then banana. This would be the order: apple first because it's occurring the maximum number of times, then banana because it was alphabetically it was coming later after apple, and then finally orange because it's occurring only once. So what would be the intuition behind this problem? To solve this problem, see, the question is very simple. If it if the question was only to sort it based on the number of frequency, then what would we have done? If there was nothing like that, just leave the alphabetical thing. We just have to sort it according to the number of times a word is occurring. So if that was the question, it would have been simple: just create an unordered map, hash map, which would count the frequency, and we would create a vector and sort that basically on the times of frequency. But this question also applies it alphabetically. So it's a rather simple question, and this is how we are going to do it. First, we are going to create an unordered map. So unordered map. This unordered map would contain string and an integer. Let's call it umap, but we got a included two. So hash include and this. Okay. So now we are going to what we are going to do is just create a frequency mapping. So how we are going to do that? For const of let's suppose just auto I in umap. So basically we are traversing the umap, unordered map, and for each element we are calling it I. So what we are going to do is not umap, we are actually traversing the words vector. Yeah. So for each word, so let's suppose for each apple, banana, and apple, orange, all these, we are basically making the frequency map. So what we are going to do is umap of that I. Now this I would be apple or banana or the specific repetition ith value that we are going to count. So we'll just increase the count. So far we have a frequency mapping of all these words, which would look like this. See, apple occurs once. This would come up in the first iteration of this. Apple occurs once, and then banana. So what we are going to do is banana is occurring once, then apple is occurring twice. So this will not add one more, but rather increase the count. So now apple is again twice, orange, and this would come again because it's a new element. Then we got banana, it will increase the count. Then again banana, it will increase the count, and then apple. So this would be the final map. So basically we have this at this stage. Now what we can do is we can sort it, but here's the catch: we cannot sort an unordered map directly using sort from this hash include sort. No, algorithm. We cannot use sort directly on an unordered map. So what we are going to do is basically create a vector which will have all the elements of this U map. So let's create that. So vector, this vector would create would have a pair, because remember, this is what we added in the U map, a string and an integer. So we have to have that same format here. So pair of string and an integer. Let's call it word count, and it would start from umap.begin and umap.end. So it will basically have all the elements of an ordered map, but it would be a vector rather than an ordered map. So now what we can do is sort it. So sort takes three things basically. From where we are starting, so we are starting from this word count begin. We would end it at the end, of course, not rocket science. And this is the comparator. So this is the custom comparator that we are going to build for it. So in case you don't know what this whole stuff is, I'll explain it to you. This part would contain the variables from all these things that we are going to include in this comparator, but we actually don't need it, so we'll just leave it blank. This would be the list of parameters that this function is going to receive, this comparator is going to receive. This is just a symbol to say that from here the body starts. This is the return type, which is optional, it can be inferred in C++, and this is the body of the function. So what we are going to take, so we are going to take pair of integer, a pair of string comma integer, and let's call it a, and let's call it const, and we need one more, so b. So basically what is the relation between these two, how we are going to return it? So if a dot second is greater than b dot second, then return true. I'll explain to you what does this mean. Basically we are saying this dot second would mean the frequency, because that's what we are doing over here. So this stands for the string or the word and its frequency, and so this b dot second and a dot second would be the frequency. So if this frequency of a is more, we'll just return true, and else we return false. But here's the catch, we also need to check for one more case, that is, what if they are same? So the frequency of a dot second is equals to b dot second. Then what we are going to do? Now see, what we are doing over here is the same as this. Apple comes thrice and banana comes thrice. So what were we doing? We were basically sorting them based on their alphabetical order. So that's what we will do here. See, if there is a tie over here, then we would check if a dot first is comes before b dot first, alphabetically return true, else return false. So now we have a thing called word count, this one. So what will this contain? It will contain apple and actually its frequency too. So it will also contain banana and its frequency, and orange and its frequency. And this would be sorted because we just did sorted it, right? So it would be exactly in this order: apple, banana, and orange, and it would be one, should be one. So, but if we see the output format, we actually see that we are not returning this as a pair of the word and frequency. We are basically just returning a list of these strings. So what we are going to do, it's simple. We are going to create another vector called answer. It would be a string and answer, and what we are going to do for auto, and let's suppose just write it completely, string and const string and integer. It would be a pair, and let's call it and, because we are taking the pointer, and I inside what, inside word count. So for every element in the word count, what we are going to do is answer dot pushback I dot first, because first one was the word, so that's what we are going to go for. And finally we'll just return the answer. So let us see if there is any error. And it says all test cases, no, not all test cases, but it's just compiling. So let's just submit it and see if it works. So yes, it's the correct answer. So there it is. Basically, let's just revise what we did so far. So we had a list of words. What we had to return was a sorted order of this in a specific format. So what we did, we created a map, a frequency map, which would have the frequency of how many times all these things are appearing. And then we converted that map to a vector so that we can sort it. Then we sorted it according to the frequency, but if the frequency was same, we sorted it according to alphabetically. If alphabetically it is come first, then we would add it in the word count first, and then we converted that sorted vector, which would contain a pair, into a vector which would contain only the string. So that's how we did it. Let's Thank you so much.